Everyone, for today's lesson, we are going to use trigonometry with right triangles. Our warm-up for today is for you to use the Pythagorean theorem to find the missing side lengths in simplified radical form. There are two different triangles. One triangle has side lengths 4 and 5, and it's asking you to find the hypotenuse. And your second triangle gives you one leg and the hypotenuse. So one leg is 9, the other one is 12, and they're asking you to find a leg. Please go ahead and pause the video, complete this warm up on your own, and when you have an answer, please restart the video and we will see how well you did. All right, let's go ahead and answer these questions. So remember that the Pythagorean theorem, that's simply a squared plus b squared is equal to c squared. So that's the formula that we are working with. So I'm going to write 4 squared plus 5 squared is equal to x squared. 4 squared is 16, 5 squared is 25. This is going to equal x squared, and 16 plus 25 is 41. So 41 is equal to x squared, and I'm going to take the square root of both sides. Now remember, whenever you're taking the even root of both sides, we would have plus or minus in our answer. But because there exists context with this problem, we will not use plus or minus. Instead, we just use our positive answer of the square root of 41 is equal to x. And there is your first answer. Let's go ahead and look at number 2. For number 2, I'm going to write 9 squared plus x squared is equal to 12 squared. So this is 81 plus x squared is equal to 144. I'm going to subtract 81 on both sides to isolate the x squared. And when I do that, I end up with 63. So now I'm going to take the square root of both sides, and I need to write this in simplified radical form. And I know that the largest perfect square factor that can go into 63 is 9. So I'm going to rewrite this as 9 times 7. I know that the square root of 9 is 3. So my answer is going to be 3 times the square root of 7. And throughout this lesson, there's going to be usage of the Pythagorean theorem, as well as writing answers in simplified radical form. So these are skills that we've talked about before, and we are definitely going to be using them in today's lesson. Our learning targets for today are for you to be able to say, I can define trigonometric functions of an acute angle of a right triangle and use them to solve right triangles. So essentially what that means is we're going to be using SOHCAHTOA as well as other trig functions and other trig things that we've learned with respect to trigonometry to help us to solve. Solving means that we find all missing side lengths and all angle measures. I can use the angle of elevation or the angle of depression to find missing side lengths of a right triangle as well. So these are our learning targets for today. So some quick vocab for you guys to know is that the ratios of a right triangle's side lengths are used to define the 6 trigonometric functions, which are sine, cosine, tangent, cosecant, secant, and cotangent. Cosecant, secant, and cotangent, they are the reciprocals of sine, cosine, and tangent, respectively. This is something that we are going to be learning about in the next couple of lessons, but for right now, we are just going to be focusing on sine, cosine, and tangent for this lesson. But eventually, we will be talking about those. So let's go ahead and recap what we already know about right triangle definitions of trigonometric functions. So first thing, we're going to let theta, which theta, if you want to practice drawing that, it's essentially the letter like a cursive O, if you want to view it like that, but with like a tail that's going on the inside. So this is known as theta. And theta is used to represent angles in mathematics. So if this is the first time of you seeing theta, this might be the first time, but it's certainly not going to be your last time. Theta is used to represent angles. So we're going to let theta be an acute angle of a right triangle. The 3 basic trigonometric functions of theta are defined as follows. So if theta represents an angle, the sine of theta, that's going to be equivalent to the opposite divided by, so the length of the opposite divided by the length of the hypotenuse. This is where we get the SOH of SOHCAHTOA. Sine is equal to opposite divided by hypotenuse. Cosine of theta, that's equivalent to the length of the adjacent side. That's the side that touches both theta and the right angle, divided by the hypotenuse. Remember that the hypotenuse is always across from the right angle. This is CAH. This is where we get the CAH of SOHCAHTOA. And finally, we have tangent of theta. Tangent is equal to the opposite, the length of the opposite divided by the adjacent. TOA, that's your TOA. And so just for extra emphasis, I'm going to highlight these letters. This is where you get the SOH and the CAH, CAH. And finally, we have the TOA. SOHCAHTOA, also known as SOHCAHTOA. So for example number 1, we're just going to focus on the 3 trigonometric functions of this angle. And I see that we have angle theta, and we want to find the sine, cosine, and tangent, but we have a problem. We do not know the hypotenuse. So what we need to do is we need to use the Pythagorean theorem to identify what that hypotenuse is so that we can evaluate the 3 trigonometric functions. So I'm going to use Pythagorean theorem to say 8 squared plus 15 squared is equal to x squared. This is 64 plus 225 is equal to x squared. 64 plus 225 is 289 is equal to x squared. And when we take the square root of both sides, we end up with 17 is equal to x. This is known as Pythagorean triple. And if you have your Pythagorean triples memorized, then you didn't really need to use the Pythagorean theorem. And what a Pythagorean triple means is it means that this is 3 whole numbers that satisfy the Pythagorean theorem. 8, 15, and 17 are 3 positive integers that satisfy the Pythagorean theorem. So now that I know what the hypotenuse is, it's very easy for me to identify what the sine of theta is. So we already have the hypotenuse labeled. Let's go ahead and label the opposite and adjacent, especially for people who are very visual. So now I'm going to write the sine of theta. That's going to be equivalent to the opposite divided by the hypotenuse, and that's 8 over 17. The cosine of theta, that's going to be equal to the adjacent divided by the hypotenuse, and that's 15 over 17. And finally, the tangent of theta, that's equal to the opposite divided by the adjacent, and that is 8 over 15. So that is evaluating the 3 trigonometric functions of theta. So now we're going to take this idea to the next level. Let's say that theta is an acute angle of a right triangle, and I'm giving you that the cosine of theta is 3 over 8. Now I'm asking you for the tangent of theta. So I think that it's really helpful to draw a quick picture of what's going on. So I'm going to draw a right triangle with theta being one of the acute angles. Since I know that the cosine of theta is equal to 3 over 8, this means that I know the adjacent and the hypotenuse because cosine of an angle is equal to adjacent divided by hypotenuse. It's the CAH. So with respect to theta, I know the adjacent side. I know the hypotenuse. What I don't know is I don't know the opposite. So that's something that I need to identify because I know the tangent of theta has to be the opposite divided by the adjacent. I just don't know what that opposite value is, so I can use the Pythagorean theorem to help me. So I'm going to write x squared plus 3 squared equals 8 squared. I have x squared plus 9 is equal to 64. I'm going to subtract 9 on both sides so that I end up with x squared is equal to 55. And now I'm going to take the square root of both sides to end up with x is equal to the square root of 55. We're going to leave our answer always in simplified radical form. If 55 had a perfect square factor in it, we would obviously continue simplifying. But since it doesn't, we simply leave it as the square root of 55. So now that I know that the opposite is the square root of 55, and I already knew the adjacent, I can now find the tangent of theta is equal to the opposite, which is the square root of 55, divided by the adjacent, which is 3. Now here's the truth. If there existed a radical in the denominator, I would have to rewrite this in simplified radical form by rationalizing the denominator. You might see that in an assignment, so I'm just putting that out there. Please go ahead and try example number 3 on your own. And when you have an answer, please go ahead and restart the video and we will see how well you did. In example number 3, as you guys can see, it was set up in the exact same way as our previous problem. So they say that theta is the acute angle of a right triangle. They're telling us that the cosine of theta is equal to 7/10, which means that we know the adjacent and the hypotenuse. So the hypotenuse is 10 and the adjacent is 7, and we just don't know our opposite. And we want to find sine, and we know that the sine of theta is equal to the opposite divided by the hypotenuse. So we need to use the Pythagorean theorem to help us to find what x is. So x squared plus 7 squared is equal to 10 squared. So that's x squared plus 49 is equal to 100. I'm going to subtract 49 on both sides. And when I do that, I end up with x squared is equal to 51. I'm going to take the square root of both sides, and I end up with the square root of 51 is equal to x. Now that I know that x is the square root of 51, which if I could simplify it further, I would, but I can't, so I don't. I'm going to write this as the sine of theta is equal to the opposite, which is the square root of 51, divided by the hypotenuse, which is 10. And there is our answer. And once again, if we had a radical in the denominator, or if we needed to write 51 in simplified radical form, meaning it had a perfect square factor in it, we would continue going, and that is something that you might see. All right, let's go ahead and flip the page and discuss a new topic, which is called solving right triangles. Now, to solve right triangles, what that means is that you find all missing side lengths and all missing angles. That's what you need to do. So finding all missing side lengths using trig ratios means that you can use the Pythagorean theorem only if you know two sides to start, or you can use SOHCAHTOA. In order for you to use SOHCAHTOA, you need to know one acute angle and one side. So it just depends on what information is given to you. So you need to know one acute angle and one side. So that is the number 1 right there. So that's finding sides. For finding missing angles, you can use trig ratio, inverse trig, which we're not going to have in this particular set of examples, but we would use inverse trig ratios. Or we would use the fact that all of the angles of a triangle add up to 180 degrees. And for our problems for today, this is going to be the theorem that we're going to be working with. It's also known as the triangle sum theorem. In our calculator, we need to make sure that it is in degree mode, since we're only working with angles that are degrees instead of radians. We're not quite there yet to talk about radians. And now I have example number 4, which says, solve triangle ABC. Find all unknown angles and sides and list all 6 pieces of information. We want to make sure that we round our angles to the nearest degree, so that's whole number, and round all of our sides to the nearest 100. So the first thing I'm going to do is write down all the information that I know and need to find. So with respect to, let me go ahead and make sure this isn't blurry. So we have sides and we have angles. Sides, we have side AB, we have side BC, and we have side AC. And AB, I do not know yet. BC, I do know, it's 13. And AC, I do not know yet. So I have two sides that I need to find. When it comes to angles, I have the measure of angle A, which I do not know yet, the measure of angle B, which is 56 degrees, and the measure of angle C, which I can see that there's a 90-degree angle symbol there, so I know 2 out of my 3 angles. Chances are the easiest thing for us to find is our missing angle, because we know that all of the angles of a triangle add up to 180. So that's going to be the first thing that I'm going to identify, is I'm going to find the measure of angle A. The measure of angle A is equal to 180 minus 90 minus 56. And 180 minus 90 minus 56 is 34 degrees. The next thing I need to do is I need to find my sides. So I need to find side AB first. Why? Because it's just, that's the order in which I wrote it. If I wanted to find AC first, I totally could do that as well. But I'm going to find AB first. This is also known as little c. So that's our little letter that we have there. So with respect to given information, this is something that we've learned about. We always want to work with given information. So I can see that I have 56 degrees and C is the hypotenuse, or AB is the hypotenuse, and I am given the adjacent side. I have an A and an H. That tells me I'm going to be working with cosine. So the cosine of 56, that's going to be equal to the adjacent, which is 13, divided by the hypotenuse, which is little c. And what's really cool is that whenever there's a variable in the denominator, there exists a trig. And that trig is that the variable and the trig expression, so cosine of 56, they flip-flop positions. And so I end up with c is equal to 13 divided by the cosine of 56. So I'm going to put this into my calculator. And I have 13 divided by the cosine of 56. And when I put that into my calculator, I end up with 23.24. And that's going to be units. We don't know what those units are quite yet, so we're just going to write it as UN, so 23.24 units. All right, let's go ahead and find AC. So AC, that is the opposite with respect to 56 degrees. And I already know, always working with given information, I know 13. So that means that I'm going to find AC, also known as little b, by using tangent. Opposite, adjacent, that's tangent. So the tangent of 56 is equal to the opposite, which is little b, divided by the adjacent, which is 13. So tangent of 56 is a number, and I can make it over 1 and use cross product. So that means I have 13 times the tangent of 56 is equal to little b. And I'm going to put that into my calculator. 13 times the tangent of 56, that is equal to 19.27. So 19.27 units is our answer. And so we were able to identify all of our missing information. Please go ahead and try letter B on your own. When you have an answer, please go ahead and restart the video and we will see how well you did. All right, looking at letter B, first thing I'm going to do is identify all of the information that I know. So I'm going to write down my sides. So that is AB, BC, and AC. So AB, I know is 22 units. I don't know BC and I don't know AC. So now I'm going to identify all of my angles. I have the measure of angle A, which is 37 degrees. The measure of angle B, I do not know yet. And the measure of angle C, that's equal to 90 degrees. So the thing that would probably be the easiest to find first would probably be the measure of angle B. And that's because it's simply a missing angle measure. And I know that all of the angles of a triangle add up to 180. So I'm going to write 180 minus 90 minus 37. This is going to equal the measure of angle B. 180 minus 90 minus 37, that is equal to 53 degrees. Cool. So I just found the measure of angle B. And now what I need to do is I need to find BC and AC. So BC is called little a, and I'm going to go ahead and find that first. So with respect to 37 degrees, which is the angle that's given to us, we always use given information. A is the opposite, and I was also given the hypotenuse, which is 22. OH, that tells me I'm going to work with sine. So the sine of 37 is equal to the opposite, which is A, divided by the hypotenuse, which is 22. I'm going to make sine of 37 over 1 since it's a number, and I'm going to use cross product. So I end up with 22 times the sine of 37 is equal to A, and I'm simply going to put this into my calculator exactly as I see it. So that's 22 times the sine of 37, and that is equal to 13.24 if I'm rounding it to the nearest hundredth. So 13.24 units is equal to little a. Let's go ahead and find AC. So AC is also known as little b, and it is the adjacent side to 37 degrees. So we want to find the adjacent. Working with given information, I was given the hypotenuse, that's AH. I'm working with cosine. So the cosine of 37 is equal to the adjacent, which is little b, divided by the hypotenuse, which is 22. Cosine of 37 goes over 1 since it's just a number. We use cross product. So this is 22 times the cosine of 37 is equal to b. And I'm going to put this into my calculator exactly as I see it. So that's 22 times the cosine of 37. And I end up with 17.57. So 17.57 units is equal to b. And so we were able to identify all of our missing information using trigonometry. All right, let's go ahead and look at example number 5. Example number 5 has a lot of words for a little bit of work. And it says, while standing at Yavapai Point, while standing at Yavapai Point, near the Grand Canyon, you measure an angle of 90 degrees between Powell Point and Whitforce. So that's supposed to be an F. Whitforce Point as shown. So we see that we have a 90-degree angle that has been measured. You then walk to Powell Point and measure an angle of 76 degrees between Yavapai Point and Whitforce Point. So here's your 76-degree angle. The distance between Yavapai Point and Powell Point is about 2 miles. How wide is the Grand Canyon between Yavapai Point and Whitforce Point? So that is X. So with respect to our picture describing our situation, we know 2 miles, which is the adjacent side to 76 degrees. So 76 degrees is about right here. And X is not across from the right angle. It's across from 76, making it the opposite side. So what uses O and A? That's tangent. So this is we are going to solve this by using tangent. The tangent of 76 is equal to the opposite, which is X, divided by the adjacent, which is 2. So now I'm going to make tangent of 76 go over 1, and now I'm going to use cross product. And when I do that, I end up with x is equal to 2 times the tangent of 76. So I'm going to put into my calculator 2 times the tangent of 76. And when I do that, I end up with 8.02. So they didn't tell us how we were supposed to round, but we typically round to the nearest hundredths. So I'm going to say 8.02. So the directions are, the question is asking how wide is the Grand Canyon between Yavapai Point and Whitforce Point? And since everything was in miles, my unit is miles. So 8.02 miles. We have one more idea to talk about, so let's go ahead and flip the page. And this is talking about angles of elevation and depression. So it says if you look at a point above you, so think about like just sitting there where you're at, you're looking at your paper maybe, but look straight, and then look at a point above you, whether it's at a ceiling, the sky, wherever you are at. So if you look at a point above you, such as the top of a building, the angle that your line of sight makes with a line parallel to the ground is called the angle of elevation. So it's your line of sight looking at a point above you and a line parallel to the ground. That's known as an angle of elevation. So in this picture right here, if you can imagine looking up at the top of a building and you are on the ground is one line and your line of sight is another line, an angle is created. This is known as the angle of elevation. Now let's pretend that there's something on top of this building. We don't know what it is. I'm going to draw something random. And this thing has a parallel line that's invisible. It's parallel with the ground, so I'm going to draw in some parallel symbols. It's parallel with the ground, and it is looking down at you. So there is an angle that is created with a line parallel to the ground and your line of sight looking down. This is called the angle of depression. So at the top of a building, the angle between a line parallel to the ground and your line of sight is known as the angle of depression. It's that angle that's created looking down. And these two angles have the same measure. And if we put our geometry brains back on, the reason why they have the same measure is because they are alternate interior angles. And we know that alternate interior angles are congruent. Congruent means that they have the same measure, and these two angles are alternate interior angles. So the thing that I want you guys to know is that the measure of the angle of elevation is equivalent to the measure of the angle of depression. So elevation is looking up, depression is looking down. And they have the same measure because technically they are alternate interior angles, and alternate interior angles are congruent. All right, let's go ahead and look at example number 6. For example number 6, it says you are measuring the height of your school building. So I'm going to draw like a quick shape of a building. We're going to pretend as if it's a building, and we are measuring the height of our building. So whenever you see the word height, that always means that we are dealing with a right angle. So this is a building. You stand at a point that is 25 feet away from the base of the school. The angle of elevation, so that's looking up from a point on the ground to the top of the school building, is 62 degrees. We want to estimate the height of the school building. So what we're going to use, according to what we know and what we want to find, I know the adjacent side. I want to find the opposite. So what uses opposite and adjacent? Well, that's going to be tangent. So that is the tangent of 62 is equal to the opposite, which is x, divided by the adjacent, which is 25. I'm going to use cross product, so I end up with 25 times the tangent of 62 is equal to x. When I put 25 times the tangent of 62 into my calculator, I end up with 47. So that's about 47.02, but they asked us to round to the nearest foot. So that's about 47 feet. So the height of the school building is about 47 feet. Last example, and it says a kite. So if we were to draw a quick kite that's flying in the sky, here's its tail, it makes an angle of 59 degrees with the ground. So anytime you see with the ground, that indicates that we are working with an angle of elevation. So this is 59 degrees. Here's my height. Anytime you have an angle with the ground, that's an angle of elevation. If the string, which here is the string of the kite, because somebody's got to be holding it, maybe it's like on the ground stuck. If the string of the kite is 40 feet, how far above the ground is the kite itself? So with respect to 59 degrees, x is the opposite and the string itself is the hypotenuse. This is O and H, so that means I'm working with sine. So the sine of 59 is equal to the opposite, which is x, divided by the hypotenuse, which is 40. I'm going to make sine of 59 be over 1, and we're going to use cross product so that we end up with 40 times the sine of 59 is equal to x. And I'm going to put this directly into my calculators, and we once again want to round to the nearest foot. So 40 times the sine of 59, and we end up with 34.28, so about 34 feet is equal to x. And that's how high that kite is above the ground, as well as the end of today's lesson. If you have any questions over anything that I talked about in today's lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.